Hello everybody, it's Mr. Clausen. I just wanted to go over how to do some potential and kinetic energy calculations. Sorry I can't be there, but I'm home sick. Hopefully I'll be in tomorrow. So in the front of the room, after you've taken your little quizzes, you should find a worksheet that looks like this. And then there's another page to it, and it looks something like that. So this is page 2, it's got some sample problems. This is page 1, and it's just got information to help you out. So if you take a look here, the part we're going to start with is potential energy. Remember that potential energy is the energy of position. And so what potential energy depends on are three things: the mass of the object, the height of the object, and then this thing here that we've been calling g, which stands for the acceleration due to gravity. And on planet Earth, that number is always the same number. The real number is 9.8. But for our class, we can just go ahead and use 10. And this is pretty common. In fact, if you look here on this worksheet, a little bit further down here in this sample problem, they use the number 10 as well. Now, don't let the units mess you up. It just means how fast something gets going fast on planet Earth. So if it falls for 1 second, it's falling at 10 meters per second. If it falls for 2, it gets 10 faster, so that would be 20. And then another third second, it would be even faster yet, so that would be 30. But for our problems, it's a lot simpler than that. We just need to use the number 10 and multiply it in there to get there. So let's take a look here at this sample problem. I got the wrong thing tapped. Sorry about that. So it says, how much potential energy does a 4 kilogram object have that is 5 meters off the ground? Now, in the problem, it looks like they only gave us 2 pieces of information. And if you look at the potential energy formula, it says that we need 3. But just remember, once again, G is equal to 10. So I have that highlighted here over on the side. So the 4 kilogram object, that's the object's mass. The 5 meters, that's the object's height. And so to calculate that, all you have to do is do 4 times 10 times 5. And if you run that through on your calculator, you would get, like they show right here, 200, and then the unit, like they have shown, is joules. Okay? So just a couple more things on potential energy. The more mass you have, the more potential energy you're going to have. So it says it over here, more mass, more potential energy. And then also, the more height you're going to have, the more potential energy. All right, let's work on to the next one, which is kinetic. So kinetic energy is the energy of motion. It depends on 2 things. It depends on how much mass the object has and the object's velocity. So like it's showing right there and there. I'll erase that so it's a little easier to see again. Maybe I'll zoom in a little bit there. All right, so to do a sample problem, let's take a look at this one. It says, how much kinetic energy does a 10 kilogram object have that's traveling at 3 meters per second? So with that information, we just make a list of our knowns and unknowns. And what I mean by that is over here, this number is 10 kg, so where does that go? Kg is kilograms, so that means it's the object's mass. The velocity is meters per second, so the 3, that's the object's velocity. And then finally, the question was asking, what is the kinetic energy? So in this list, we say kinetic energy equals question mark. So to put our numbers into place, we have mass times velocity squared. So we just plug the numbers in where they belong. There's the 10 for the mass. There's the 3 for the velocity. And all you have to end up doing is squaring that 3. So 3 times itself is, 3 squared, so 3 times itself is 9. Multiplied by the 1/2 times the 10. 5 times 9 is 45. And once again, this is energy, so it's measured in joules. Last thing to realize about kinetic energy is the more mass you have, the more kinetic energy you will have. And finally, the more velocity you have, the more kinetic energy you will have. So let's take a look at what this is really just about, because this is all review for us so far. And that's the second page, and it just gets practice with it. So the first one here is we are dealing with units. So in this first problem, it's got a whole bunch of different letters here: force, velocity, P, H, W, capital P. And so I will help you with a couple. The one down here is power. So number 6 stands for power, and that is measured in watts. So that's something that we haven't necessarily talked about in our class. So you put that in right there. The other one that might be a little bit tricky for you is this one, number 3, and that's lowercase m is momentum. And if you recall back, momentum is mass times velocity, so that'd be kilograms times meters per second. So this would be 8 kg meters / seconds. All right, the rest are totally within your wheelhouse and you can handle it. So you got to do force, velocity, height, and then work or energy. And energy will be straightforward. Over in this section right here, it's just match the definition of the word with the vocab word. So there you go. Here you're supposed to identify as an example of, here, you can't even see where I'm pointing. Here, you're supposed to identify, is it kinetic or potential energy? And then this one, you just circle the one with more potential. And then in this one, you circle the one with more kinetic. Okay? And so those are concept reviews, just getting us there. And it's going to get you down into some sample problems. And I will help you out and do the first one on each side for you. So let's take a look here. Calculate the potential energy of a 5 kilogram object sitting on a 3 meter ledge. What we want to do is just identify what the problem has given us. So if we take a look there, it's asking for potential energy. So we can say potential energy equals question mark. It says 5 kilograms in 3 meters. You'll notice that I just underlined the words that had numbers next to them. So we've got to figure out what the 5 represents. So 5 kilograms, if you remember, kilograms measures mass. So we now know the mass. And meters, so the 3 meters there, that's going to measure the height. And if we look back up at the top of this sheet, which we could zoom out and go all the way up here, or you have it in your notebook, you can see that potential energy is equal to mass times gravity times height. So now I'm going to zoom back in down here. All right. So potential energy is equal to mass times gravity times height. And all we have to do is plug the numbers in where they belong. So in this case, the mass was 5. Gravity, if you recall, I said is just the number 10. It doesn't matter what problem we're using, as long as we're on planet Earth. You're always just going to put 10 in there. And then the last one, h for height. In this case, it was 3. So we're going to do 5 times 10 times 3. We know what that is, but it's okay to bring out your calculator to help you out with this. So there's mine. I don't want to support dark mode. That's okay. And we're ready to go. So I'll clear that out. Excuse me. 5 times 10 times 3. And I hit equals. And the answer is 150. Now remember, this is potential energy. So the unit we would put on that is joules. All right. We good? Let me get that out of the way. That really wasn't out of the way, but now it is. And let's take a look now at this one over here. A rock is rolling at 10 meters per second. Find its kinetic energy. So let's list out what was given to us and what we need to find. Kinetic energy is what we're trying to find. They gave us 4 and 10. So 4 kilograms. That's the object's mass. 10 meters per second. Meters per second. That's a velocity. And now what we need to do is just pull out the equation for kinetic energy. I'll let you look that up in your notebook or at the top of this page. All right, good. It's 1/2 mass times velocity squared. So all we need to do is plug the values in where they belong. Our mass is 4, and our velocity is 10. And then here's the thing that everybody forgets. Don't forget that little squared up there. All right, let's run through and do the calculations. 1/2 times 4 would be 2, and 10 squared would be 100. So 2 times 100 would be 200 joules. And that's the kinetic energy. Okay. All right. So the only one that's a little bit confusing to you, there's two of them here that changed up a little bit. On this one, they're just telling you it says a 25 Newton object is 3 meters up. All I want you to do is just take that and have that say 25 kilogram object just 3 meters up. Then this hint isn't needed, and you can do the problem just fine. And then the other one down here, it says find the work. You don't have to do this one, so you can skip it if you want. But for those of you that want to know, work is equal to force times distance. And so this problem really isn't all that hard now that you know that the amount of work an object done is equal to its force times its distance. All right, so I'd like you to get all the questions answered. I will bring in all the solutions to these answers tomorrow. They won't be in this video, but I'll bring them all in, give you the full solutions. And yeah, so hopefully that helped out. Actually, scratch that. I will put the answers to this worksheet in the daily notes folder so you can check your work, and then that way I'll also know if you watched the video to the end. Hopefully that helps. I will hopefully be there on Tuesday. Like I said, I'm staying home sick on Monday. Do the best you can, take the little quiz to practice, and then we'll get going on this. All right, talk to everybody later.